So we've talked a bit about inverses. Now we're going to do inverses of exponentials and logs. So if we have f of x equals some log with base whatever, and g of x is a to the x, then f of x and g of x are inverse functions. This means because they're inverse functions, they meet on y equals x. So y equals x, y equals x. So what have we got? A to the power of x is a to the x. A to the power of log ax is x. So that's handy things sometimes to know, because you'll be able to simplify expressions much easier if you know that those expressions are true. All right, so what do you want to do? Find the inverse function. We should hopefully know by now to find the inverse, swap x and y. We've been doing that since, last December. So we go x equals e to the y plus 2. Take 2. So log base e of x minus 2 equals y. So the inverse function, f minus 1x, is the natural log of x minus 2. Find the inverse function. State the domain of the inverse and the range of the inverse. So what I'm thinking is I'm just going to do a little sketch, see what this looks like. It's an e to the x that's been moved up 2, so there's an asymptote at y equals 2. What was 0, 1 in the original has been moved up, so it's now at 0, 3. So the domain of the inverse is the range of the original, which looks to me like not quite 2 to infinity, neither included. And the range of the inverse is the domain of the original, which looks to me like it was all the numbers. So there we are, we have the rule, the domain, and the range. So you need to just practice some of those by doing exercise 5H. Now I'm going to work through some of these. I won't work through all the questions. It's just some of the exam questions are more useful than others. What I'd like you to do is have a go at them yourself. Stop the video, see how you go. So let's have a look at this one from 2010. Find the rule, 2 things, the rule and the domain for g to the minus 1, the inverse. So inverse swap x and y still. X equals 2 log e, y plus 4. Sorry about the quality of the copying, plus 1. So I'm going to go take the 1 and then divide by the 2. So that would mean that e to the x minus 1 on 2 equals y plus 4. So subtract the 4. The inverse function, g to the minus 1x, because that's what we're asked to find, is equal to e to the x minus 1 on 2, take 4. So that's the first thing. Have I finished? No, I have not, because what do I want to find? The domain. The domain of the inverse is the range of the original. So the range of the original function was all the numbers. So that's going to be R. Then for the second bit, on the set of axes above, sketch the graph of the inverse function, g to the minus 1. Label axes intercepts with their exact values. So what do I know? I know they meet on, this is a really hard grid. The graphics have got better since then. So what I'm going to do first is a line of y equals x. Well, that's messing with my eyes, because that's where I know they have to meet. So when I go to draw my new one, I know it has to meet there. I know that this asymptote that was at x equals negative 4, we're now going to have one at y equals negative 4. And I've got to label that with the equation. And then I think about the shape. It's a reflection in that line y equals x that we've drawn in. So I know that it is in fact going to look like something like that. So it's got to meet here, and I've sort of done it not quite curved enough. Well, that's a lot. So sort of like that. Just to make sure that shape is nicely reflected so it's even on each side. So what does it say? Sketch the graph, done. Label the axes-intercepts with their exact values. So we're going to have one here, which is, I'm just trying to work out, when I did my answers I forgot to do it. So the axes-intercept, I'm just going to say when x equals 0, the inverse function of 0 is e to the minus a half minus 4. All right, so it's like saying 1 on the square root of e, which is about 1 on the square root of 3, take 4, so it's negative. So when x is 0, this point here is 0, e to the minus half minus 4. That's a lot, isn't it? And then the other one I might say is what was g of 0, because we know that that would swap. So g of 0 was 2 log e4 plus 1. So that's my other intercept, which is here. It's going to be okay, so we've made sure that we've labelled both of those. Hopefully they're right. So I haven't got the answers in front of me because I forgot to do it last time. So let's have a look at, this is still the same exam 2. So the first thing they do, and this will happen all the time, is we talk about it with numbers, but now instead of numbers we're going to use letters. So we've got K, A and C. So the diagram shows part of the graph. The graph has a vertical asymptote with x equals -1, okay, a y-axis intercept at 1, okay, and point P has coordinates P10. So the first thing we need to do is state the value of A. Well, ordinarily if we draw a log graph, it looks like this. So in this case, it's been moved 1 unit that away. So that means A must be 1 because that A tells us about the horizontal translation. And find the value of C. So how far has it been moved up? So I'm going to say it's got a y-intercept at 1. So it goes through 0, 1. So K 1 plus C, that's what y is equal to. Log of 1 is always 0, so C equals 1. Or you can just think it's been moved 1 across and 1 up, but there's a bit more work for that second one, I reckon. And that's all we could do with that question. So let's go through to the multiple choice, remembering that we can use our calculator here. So I would define f of x, then define g of x, and then just simply write into your calculator g of f of x equals, and it just spews out the answer. But this was probably 2010. You guys are getting smarter. I don't know whether you get one that easy. Function f has a rule that f of 5x, again, I'd just define f of x and then write in f of 5x, or you could just do it by hand, couldn't you? Because f of 5x is just replace 5x instead of x. And then if that doesn't match any of the answers, so we go log e. This could be 10 cubed, 1000 x cubed. So y is equal to 1000 x cubed. Question 5. Look, I look at this. I don't know what the graph looks like, but I don't have to. Let the rule for the function of g be whatever, and just draw it on your calculator. And if you do that, you sort of get something that looks like, you do it, because obviously you have to, something that sort of looks like that. So it ends up being everything except for 2 on the x-axis, and then the range is all the numbers. So, look, this one, I'd just solve. 4 to the x equals e to the k. Remember to put your times in. Just solve that for x, and it just tells you that it's 4x. Oh, no, it doesn't. It tells you. I got that it's log 4. Just check, but it's just put in your calculator. Not too tricky. All right, so now we get to exam 1. So this is by hand, so that can sometimes be a bit tricky. Find the inverse function. Now, hopefully we go, okay, let's swap x and y. We've done it a lot, haven't we? So at 4. Now I'm going to multiply by y. And then I'm going to divide by the x plus 4. So you might be able to do this quicker. Go for it, by all means. So find f minus 1. I haven't found f minus 1 yet. I found y. So I'm going to change that to f minus 1 x. Look, back in the day it's different now, but when it says find the inverse function, usually you'll be asked to find the rule, but if it wants you to find the function, you need to write it out as f to the minus 1 such that, and then we'll have the domain onto R, and then the rule. So usually I think nowadays you'll get asked to find the rule and the domain, but this is just an older question, but still it might pop back up, so you want to make sure you get it right. So what you need to do is put in the domain here, which is the range of the original. Sorry, that's the wrong way around. Sorry. We want to find the domain of the inverse is just the range of the original. So let's think of what this graph looks like. It's a hyperbola, like it's a 1 on x, but it's a dilation factor, which doesn't matter. And then it's been moved down 4. So it's y equals minus 4. And it's got 1 here and 1 here. So its range was all the numbers except for minus 4. So I'm just looking at any restrictions. I just did it a little bit different. So the range of this was R except for minus 4. I think that's right. I think what I've got written on my screen in front of me is wrong. I think that's right. Okay, I will keep going. If you want to keep watching, by all means. But just make sure you do these, and then this will just give you a bit of help. Even though this has got some trig in it, it doesn't matter. I know we haven't done it yet, but you can still do it. F of g of x, this should be okay. F of cos x, which is 2 cos x minus 5. So that's not too bad. Find the rule for the inverse function again, swap it. Divide by 2. So that means y minus 1 equals e to the x on 2. So my inverse function is e to the x on 2 plus 1. Find the domain of the inverse function. Well, the domain of the inverse is the range of the original. And if we think about this log graph, it's a log that's been moved 1 across. Either way, its range is all the numbers R. I'm going to stop there because I think you can just have a look on the notes and you should be able to get all those answers up. But please, it is very, 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 very important that you work through those questions. It's the most important thing you can do.